Welcome to Wize Commerce Technology Sessions. So in this talk, in this discussion, we'll be discussing about the event-driven platform that we have in Wize Commerce. So today I have with me Dennis Durkin, Jay Sharma, and Joe Fu. So to start with, can you explain a little bit about the project to set the context?
As the old company as NextTag, we were a product shopping comparisons site. But our new focus is going to be on being a platform for other companies to leverage. And as such, we need to be able to handle a much larger volume of data, which also means being able to process that data quickly and make it available for our partners within minutes, ideally.
So currently we are working on a project where we are replacing our legacy infrastructure with a new, more reliable, more scalable, real-time infrastructure. The goal of this project was to reduce end-to-end data latency to 10 minutes. So with this goal in mind, we started working on this project in the beginning of this year. So Wize Commerce infrastructure has two main components. We have our own custom search and a highly scalable cache system. In the legacy infrastructure, these systems were batch-oriented, where our end-to-end latency was 12 hours. These systems were using Hadoop, MySQL, Oracle, then Memcache. So in new infrastructure, we replaced a couple of these technologies with the latest technologies. So this is how our new system looks like. We replaced our system of record from Oracle to HBase. Now we are using Solar version 4 for searching, which is near real-time system. Similarly for cache, we switched from MySQL to Cassandra.
We were updating our search system to solve a lot of issues we have. Our legacy system is fairly traditional. We have a bunch of feeds from our partners, and we process them into an Oracle database, and then we have jobs to read off the Oracle database and index it into a Lucene index, which we built offline, and then we push the Lucene index out to our search service, and that's how we search our traffic. So one of the issues we have is, as we grew, the number of partners grew, and we have a single bottleneck and a single machine where it's a relational database, and we keep getting a bigger and bigger machine, but that has limits. So going to a system so one of our key criteria that we could scale it horizontally, and since a catalog is pretty much doesn't really need all the features of relational database, because each data each object is relatively independent of each other. So if we have a data store that scales horizontally, it's relatively easy to add machines as we scale, and by reducing our latency, we can support a lot of features that our partners have been asking for. One of them is, if our latency, as it is carrying 8, 10, 12 hours, you can't have flash sales, which is sales that last for a very short period, because by the time the sale shows up in our site, it's pretty much over. So reducing latency to within minutes, like 10 minutes is our goal, allows, for example, a partner to have a sale, push a record through our API, a product through our API, have it show up on our site within minutes, and start having clicks flowing to their site so that they can handle the sale. And when they run out of stock, they can send another message to our system, and it will flow through our site and update our site and basically remove that sale from our search. And that gives a better user experience too, because the user won't be hitting on a sale, going to our partner site and seeing that the sale is over. Conversion is higher because you don't have users going to our partner site and hitting a product that's no longer available. So there's a lot of advantages for reducing latency.
The new system that we've created is an event-based system to process in near real time. We have import process, which is generating events and publishing these events to queues. We have a number of subscribers to these events, including our search and cache systems. They subscribe to the events and pull them down. Events are typically lightweight. They only contain the table name, the row key, and the columns that have been updated. And so during processing, one of our stages would be to fetch that data from a data store and get the full data. We potentially manipulate that data, either applying, changing column names, reformatting data, possibly some business logic, and then we have additional stages in the processing to store that data in the final destination, either Solar or the cache. One of the advantages of Storm is that each of these stages, you allocate a number of threads across the cluster to work on each stage. And so you can check the latencies that you're getting for each stage and scale them up to try to balance the throughput through the system. And so it makes it very easy to scale up.
Wize Commerce, we have our own experiment framework for A/B testing. So we were running both the legacy system as well as the new system in parallel in production. So we allocated some percent of traffic to our new system. So we saw some RPV, the revenue per visit degradation with the new system. So we rolled back our new system, then we fixed some issues, then again we rolled out the new system, and that's how we take it to production.
Solar came along and had a lot of wrappers around the scene that makes it easier to replicate. It's easier. They are easier to update the index in real time, so we don't have to build the index offline and push it on. We can actually update the indexes in real time. We are at a point where these technologies are mature enough, and we can actually start using them to improve our search systems. So Solar has the feature of near real-time search, where instead of building the index offline and then pushing the index to the nodes, you can actually update it and have it replicate across the system in near real-time, which means within a few minutes.
So for indexing, we reduced our index latency. Earlier it was like 12 hours. Right now it is 40 minutes. We are still working on reducing it to 8 to 10 minutes.
Okay.
That's a goal.
And from the caching point of view?
It's similar from cache, that updates before could take potentially hours, especially if we were handling a large volume of updates, whereas now we're handling them in minutes.
So what are some of the lessons that we learned from this exercise by moving to an event-driven system? I would open this up for all of you, starting with Dennis.
Sure. So one of the big lessons learned is try to keep each of your stages as small as possible. Don't share resources, no singletons. You don't need connection pooling. If you have a limited resource, only allocate that number of threads to that stage. It lets you, it should be faster and lets you scale up easier.
Yes, so one of the lessons we learned while working on Storm was we should use the persistent queues to make our system completely reliable. Initially, we started with the non-persistent queues, but we faced some challenges, some issues, some data loss issues. So finally, we switched to the persistent queues, and that solved the problems.
Right. So you're going to add something?
So even though using events-based system is pretty much tailor-made for our use case, which is updating the catalog and search and cache, it's a really different way of thinking, and you have to basically switch your way of thinking. So in traditional system, even you run your job, it succeeds or fails. If it fails, it has errors. You look at the errors. In the event system, it's more like plumbing. So you're actually looking at the job holistically as if it was plumbing, and everything flows, and you're looking at flow rates, You're looking at error rates. So you don't stop a program and look at whether it's succeeded or failed. You look at what the error rate is, and it's a closed system. So in the queuing system, you have producers and consumers. So errors are actually an error producer, and things slow down. You have blockages as if you have a plumbing issue. You have to watch, like if you have errors, basically a leak, and nice thing about having a 10-minute latency is, whenever you have something come in, it shows up on the site 10 minutes later. On the flip side, if you have an issue, it shows up on the site 10 minutes later. So you have to have very good monitors to make sure that, for example, if error rates go beyond a certain amount, you stop an import. I mean, we are dependent on external data, so if, for example, some partner misprices something, it used to be we run a batch job, build the index offline, we run some validations and say, hey, it's something wrong, a lot of the prices are pennies, and then we don't deploy it. But in a system that's flowing, the feed comes in, it's wrong, it shows up in the site, so we need to have a lot of validations in line, and validations in line means monitoring rates. And you have to stop that feed, and the other nice thing about having a 10-minute latency is that even though errors show up in the site 10 minutes later, any fixes you make to roll it back also shows up 10 minutes later.
Okay.
So it's just a different way of thinking about programming.
So this concludes our session on event-driven architecture that we implemented on Wize Commerce.